Anybody heard about N-rays before? No. So, Nathaniel, thank you for digging this out and educating us. Yeah, so believing in whatever you want to get is not enough, obviously. And I hope that this is not how you do your science. You always have to have control experiments and maybe disproving experiments. This is really very dangerous. But it's interesting how many people believe him. Basically, you have some peer pressure to say what everybody else is saying, and nobody is willing to say that the king is naked, right?
It's a classic example of that type of story.
Yeah.
The emperor had no clothes, and no
Yeah.
one noticed until it was pointed out right in their faces.
Yeah. All right. Any other comments? All right. If no, thank you again. And our next speaker is Prima.
Thank you. Wait a minute. You go. Okay. Can you hear me?
Yes.
Nice. Okay. So hello, everyone. My name is Frima, and today I'm going to talk about an article that got attention in the internet, but not for the reason you really think it is. So first, I'm going to talk about the article, show you the background, and explain its main idea. Afterwards, I'll show you how they demonstrated the experiment to show you that they took their idea seriously and were transparent. Afterwards, I'll show you their downfall of what went wrong in their article. And by the end, I'll show you what happened afterwards and the conclusion. And I'll summarize everything up. So now I'm going to explain briefly the background of the article, since we are all physicists. So basically, lithium metal batteries are very promising for high energy rechargeable batteries. They have low electrode potentials and high capacity, which makes them efficient and powerful. Lithium metal also very stable, making it an excellent choice for the negative electrode in batteries. This stability ensures the batteries last longer and work reliably. However, the development of dendrites on the lithium metal anode poses a significant risk by potentially causing short circuits, which can compromise both the safety and the lifespan of the battery. Dendrites are needle-like, just as you can see in the picture, that can pierce through the separator, leading to the internal short circuits and reducing the battery overall performance and reliability over time. So basically, this study discovered that a composite separated by name of CuMOF-ANFs effectively prevents lithium dendrite formation due to its enhanced surface area and pore structure. So as you can see in the article itself, it's been written a recipe for their experiment of how they make such composition. Not unlike the Sean, where he just posted the data and the graphs without any kind of explanation. So here we can read mixed copper nitrate dehydrated with distillated water, and the picture, as you see down, are the scanning electron microscopy images of such CuMOF amps of the exact experiment inside the paper. So again, what I wanted to emphasize here is that they were transparent and gave us the recipe for their experiment and didn't fabricate it really. However, its article gone wild in the internet. And here you can see it's been on LinkedIn, in Twitter formally, and in Threads, where we can see that there been an article textual mistake here. So they accidentally didn't remove the part, certainly here is a possible introduction for your topic, which is very questionable sentence. And it's, I mean, it's been in Facebook and yeah, and the paper has been in the internet and so on. So after the allegation, what happened to the paper? The paper had been retracted, but not only because of the wrong usage of large language model program that's been used inside the paper. So here's the journal response to such allegations. This article has been retracted at the request of editors-in-chief and authors. The journal was alerted to the presence of duplicate images appearing as figures 1 and 2 of this article, and figures 1 and 2 of International Journal of Hydrogen Energy. And investigation by the journal confirmed substantial duplication of text and image data between these two articles that were submitted and published in close succession. All authors of the International Journal of Hydrogen Energy article also authored the Surfaces and Interfaces article. In addition, there are concerns that the authors appear to have used generative AI source in the writing process of the paper without disclosure, which is a breach of journal policy. The journal sincerely regrets that these issues were not detected during the manuscript screening and evaluation process, and apologies are offered to readers of the journal. So basically, not only the group have used AI source, but they've copied the figures as well. And here are the claimed figures that the journal have published. The left side, we can see that's the retracted article. And on the right side is the previous article that they've copied from. So it looks the same, especially B looks the same. And yeah, and C and D as well look, I mean, they've been swapped, I guess. And the angles in F are the same. And basically, this is the figure 2. I mean, they look almost the same, especially in figure A, but in figure C and D, they're not very the same, I guess. But figure E and F, they look almost exactly the same. And basically, this is the article itself. We can see here that the group is almost the same, but in the retraction, there is another person that's been added to the group. Yeah, it's also almost the same. So after that, I've evaluated between these two articles, I tried to look the citations of the retracted article. So I looked at the Google Scholar to see if there are any citations. And here I saw 2 articles that basically give solution of how we can avoid making such mistakes as scientists. Basically, because of the article, the scientific community pushes forward and gives us solutions of using such programs in a reasonable manner. So despite the fact that the group had made a mistake, people took advantage of it, I guess, and talked about how in science community we can avoid, using ChatGPT, but not in such blunt way. So we can learn from the article that always be honest and transparent in research. If you use AI tools, make sure to just say it. Make sure all your figures and text are original or properly cited. Copying can hurt your credibility. Authors and journals as well need to check for errors and duplications carefully to avoid flawed publications. And use AI tools responsibly and always acknowledge them to keep your research trustworthy. So to summarize all my presentation up, we explored a research field article that gained notoriety for controversial reasons. We began with an overview of the article and its significance. We discussed the importance of lithium metal batteries, particularly its stability and high capacity, and the issue of dendrite formation, which can lead to short organic framework composite separators, which aim to prevent dendrite formation. We reviewed the detailed experimental procedure and SCM images of such composition, demonstrating the transparency of the research methodology. The paper received public attention due to alleged use of AI tools like ChatGPT. The article was retracted because of duplicate images and undisclosed AI usage, which violated journal policies. And we conclude by emphasizing the importance of ethical research practices, ensuring originality and responsible AI. Thank you for listening. Open to any questions.
Great, thank you. So I want to understand, some data was duplicated, but not all of the data?
They copied the figures, and basically it's almost the same material.
But are there any other figures in the paper which are original?
No.
So basically they recycled other people or their own group previous results and used AI to write new text.
Yes. It's
okay.
almost the same, but they've added Maxine. They didn't add Maxine.
Okay. So there is a clear misconduct here, not only use of AI, but clear misconduct. What I'm really surprised, there are nowadays, all the journals run some kind of plagiarism filters on any new submission before they send it for review. And it seems like it went through all the process without any filters to point out plagiarism.
Yeah, they plagiarized their own group article.
Yeah, it's okay. It doesn't matter whose, but the fact, nowadays, when you submit something, all journals have some kind of filters. And they point immediately, if you see something that has some high content which is plagiarized, it's flagged and stopped at the beginning, not at the end. Here, the paper was accepted, published, and only then retracted.
Mm-hmm.
So what it tells me is either this journal doesn't apply filters or the filters are not good enough. Any comments? How do we make, yeah, go ahead.
Not directly related, but what is the state of using similar to AI tools, but for example, Grammarly in writing papers, like grammar corrections and all of that?
That's totally fine.
Oh, okay.
Why not?
Yeah, no, I mean, I saw now
I
that,
mean, Microsoft Word had this long time ago. That wasn't an AI per se, but you can always use tools to improve your language and grammar. Why not?
yeah,
I don't think there are any, on the contrary, people want to read and understand. And oftentimes in old days, you had groups coming from non-English speaking countries writing really bad English papers. It's very hard to read. In the
yeah.
very old days, editors would fix the English themselves.
Okay.
But I don't see any reason why not to use such tools. Obviously, anything which is creative should not be used or used, first full disclosure, and still it needs to be original work, not, work that you rely on others and you basically
Yeah.
plagiarize.
Okay, thanks.
But yeah, in China for a long time, the incentive was number of publications, you would get money, increasing your salary and so on. If you get to high impact journals and if you have more papers, you get more money and so on. And this type of incentive obviously drives people to use AI to generate a lot of papers. So this is an example, and all the journals put basically all kinds of filters to stop this. The Chinese government itself is now kind of retracting, and they want to raise the quality of science coming from China, so they are changing the incentives. Any other comments? All right, if no, we'll go to the last presentation of today. This is Yoden.
Thank you. Can everyone see the screen?
Yes.
Great. So I want to talk about what's called cold fusion, or more officially, the Martin Fleischmann and Pons electrochemically induced nuclear fusion of deuterium. And we talked a lot about holy grails in some of the lectures, and fusion is indeed one of those holy grails of energy production. So a very quick background of what happens in nuclear fusion. As we all know, Einstein's famous equation, E equals mc squared, correlated between mass and energy. And once it was discovered that the binding energy has a curve, which is a curve that we see over here on the left panel. This means that if we take heavy isotopes and convert them to small ones, or on the other hand, small isotopes, small nuclei, and fuse them together to big ones, we get some sort of mass deficiency, which is the energy that we can produce from such processes. This is what produced the nuclear bombs, and now is being attempted to be used at energy. And during the 1980s, late 1980s, 1989, Fleischmann and Pons, Martin Fleischmann and Henry Pons, two electrochemists, hypothesized that you can perform some sort of fusion, not through the usual processes that people thought were applicable, such as applying very, very large heat or trying to create some sort of small sun on Earth to fuse the two hydrogen particles together, but rather through an electrochemical processes. And what they tried to do is they tried to do it through electrolysis. They took, I'll show you the diagram. So they took heavy water, which is comprised of deuterium elements plus D2O plus oxygen, applied a current through the anode and the cathode, measured the heat of the of the entire cell, and they wanted to see if such a fusion process could occur through chemically induced processes alone. And I want to go real quick back to the previous slide So what they were looking for is they were looking for some sort of fusion process between the two deuterium elements, the 2D that we see on the left here. And what they wanted to see is that if we can measure some sort of new particles that will be created through a fusion process and can only be created through a fusion process alone, that is tritium or a neutron. And another thing that they also wanted to see if some sort of heat was measured. And they performed their experiment during March 1989. And well, one other thing that they did want to measure as well is to see if some sort of gamma ray emission occurs due to the fusion process of, well, nuclear process of hydrogen plus neutron. And in 1989, they claimed that they were able to prove that fusion can occur through a chemical process. They claimed that they measured small amounts of neutrons in tritium, and they claimed that the water temperature all of a sudden, very unexpectedly, rose from 30 degrees to 50 degrees centigrade. And they also claimed that they recorded gamma rays. And they were very excited about this discovery. And I can show you the scheme here of the gamma rays that they recorded. And the university was also very excited about this discovery, specifically the University of Utah, where one of the labs was positioned. And they were basically so excited, so they held a press conference on March 23rd, where they announced a discovery. At first, they say they're going to send the paper to Nature, but then later on, they send it to a different article, a different journal. And immediately after they made their announcement, the media also caught attention of this. And all of a sudden, news all over the United States started spreading around that cold fusion, which is the term that the media gave the experiment. Martin Fleischmann, Stanley Pons gave it a more scientifically, but also a more boring name, which didn't get much attention. And the media called it, specifically the New York Times, if I'm not mistaken, cold fusion. And this made people very excited because what it meant was very easy, accessible energy could be easily attained, almost literally from thin air. And what happened was that after the discovery was, after they announced in their press conference, many labs around the world started raising lots of questions. First of all, the big question of how does it actually happen? And which is something that was inexplicable. Like, how can you actually form an electrolysis process, fuse two nuclei together? And many labs around the world try to recreate the result. So we're going to go now through a very long list of labs. I narrowed it down to 4 or 5 that were the major, had the most consequence about what happened in their response from the experiment itself. But it's very important to remember that the summary here is an entire process of you have many labs, most of them claiming that they couldn't recreate the experiment. Then you have another lab in another place in the United States claiming that they did measure neutrons or that they did measure some heat. So it was an entire process that also all of this is well being reported on media around the United States and around the world. But the bottom line is that no lab was capable of fully creating their experiment. Many labs around the country tried to recreate the experiment. They tried to measure heat. They tried to measure neutrons or tritium or gamma rays, but all were incapable of doing so. And we see one lab measured 1 degree of heat, and the biggest one who kept their results afloat was the Texas A&M lab, the one listed at the bottom, which claimed they actually measured tritium and some neutrons. But then once people delved deeper into the way and the method that they conducted their experiments, then some raised the question that they don't rely on the way they measured their detection, the way their detectors actually were capable of detecting tritiums or neutrons, due to the fact that they also yield false positives. So this is a process that took another few months. In the entire process, Fleischmann and Pons, mostly Fleischmann, dig in their heels and they say that their experiment is true, that they have no idea why everyone else is incapable of recreating it, but they're saying that they did everything correctly. And this goes on for a few months, and all of this was happening while the media is very, very closely following the story and trying to tell everyone of what's going on. And from this very, very huge hype, they coined another term, which was fusion confusion, which no one knew exactly what's going on with this, whether it's a true experiment or not a true experiment. And after a while, towards April, May 1989, most physicists claimed that their experiment was false. They didn't claim it was fake, but it claimed that the concept of cold fusion cannot be recreated. It doesn't explain the known physics at the time of how fusion can be attained. And you even have the United States Department of Energy, which said that the results were unconvincing and they decided to not invest any money in it. And you have also the American Physical Society, which held a panel. And in the panel, out of 9 head speakers, 8 said that cold fusion is dead, and the 9 declined to make any remark. The 9th declined to make any remark. Fleischer and Pons never retracted their paper. They continued to claim that the results were true, that the results are that they did their experiment correctly, but the response and the fallout from the media was so devastating that by 1995 they both had to leave the United States and continued working in Europe. Pons never made any public declaration, but Fleischmann continued to claim that the cold fusion was achieved in his lab. And Fleischmann eventually died in 2012, and in his obituary, the big headline was cold fusion claim never replicated. So a lot of people raised speculations as to what were the problems in their experiments, and why were they able to measure such great success. And some people claim that maybe they made some mistakes, but due to what they called pathological science, they were convinced that that their experiments were true, that the results were true, and that they truly believed that they actually achieved cold fusion. And I think this is a great example of how media attention, how basically popular science or how being popular can actually turn someone into doing not full science, but the chances are that something about their detectors were flawed and they just went with it. So in conclusion, the cold fusion experiments were never successfully replicated. And the labs that did claim success either ended up retracting the papers because they had to accept the fact that their initial success did not amount to an actual one that could actually hold the cold fusion afloat, or other scientists pointed out to false manners to which they conduct their experiments. And many questions were raised about the Fleischmann and Pons experiment. And that basically was the end of cold fusion. It started out with a bang and just died very quickly. So thank you for listening. I decided to put this picture here. I don't know if many of you watch any television or if you have time to watch television, but if you watch the new Fallout series, and that's a cold fusion cell, which they decided to put as in a new method to harness energy. And some of you might say, well, that's kind of science fiction. What does it have to do with this? And we'll say, well, cold fusion is science fiction as well. So I guess the only thing that came out of it is some sort of popular science concept, which can be used in TV shows and movies. So thank you.
All right, great. Thank you. Maybe just personal recount. I was at my last year of PhD in '89 and making my way to New Jersey to Bell Labs. And, you know, I remember this vividly. Everybody in all physics department all around the world were talking just about this. And from the very beginning, people were absolutely sure that it's totally bogus. I think if I recall correctly, there were quite a few teams who tried to not only replicate, but try to explain what they have measured and why it's wrong. So I think there were such papers that basically try to explain the experiment. Obviously, nobody was able to replicate. Another, I think, very interesting point here is that they chose to go ahead with a news conference before they submitted the paper. Nowadays, you put your paper on arXiv or bioRxiv or whatever, and but here they went out even before the paper was submitted, accepted, whatever. They just went with this big flash on this unbelievable claim, and only then submitted the paper, and so the community had time to respond and to really resist this crazy idea. And as you said, even today, people talk about cold fusion. That is such a famous case that everybody knows about it. All right, thank you. And Yarden's presentation is now open for discussion. Questions? Anybody?
If there are no questions, I have one remark about what you said about sending the paper for a journal and then talking about it. They initially collaborated with another scientist who was very excited about their experiment, and I don't remember his name. I can look it up. And they agreed to make a joint paper and send it, the three of them, to Nature, and on March 24th. But I guess it was their doing plus pressure from the University of Utah, which wanted to make like a bombastic like claim. So they ended up doing a press conference the day before without him. And so basically they went to the popular way and did a crime against science and also a crime against another person who they agreed to publish the paper together with. He ended up sending his paper alone the day after to Nature.
And was that paper accepted?
I don't think so. I think it was also I tried to figure out, but the story doesn't exactly say. I didn't follow much of what happened to his paper. I don't know if it was accepted or not. I think it wasn't.
Okay. Anything else? Any thoughts from anybody?
I think also what I talked about today, what you talked about today again, is the fact that they don't retract at any point. They just keep going with it. Almost if they're too steeped in it. They just got to keep going, pretend as if it never happened, when that's clearly never the way to go.
Yeah. It's actually a very sad story. They destroyed their careers and they were never exonerated. So I'm not sure that's the right strategy, right? Anything else?
I just didn't see a way out. I guess once they made the claim, like they couldn't. Yeah. It's one of those moments like, okay, they couldn't accept it. So fake it till you make it.
Unless one of you will show the world how to do cold fusion. That's also possible. It would be fantastic. Okay, guys. I think we are done for today. We have one more meeting next week. We'll have 3 more presentations. Any other comments to me? All right. If no, have a good evening, and we'll see you next week. Good night.
Good
Good
night.
night.